Okay, this is a quick summary of how to use the first derivative and second derivative in curve sketching or recognizing a curve. And I'm just going to use either a parabola, y equals x squared, or a cubic, y equal x cubed. And if you just see this and can remember this, you can do it all. So let's go with a parabola. So there's y equals x squared. First derivative equals 2x. That's a line, so plus 0, right? mx plus b. Y double prime is 2. It's a constant. And it's positive. So, in a parabola, the second derivative can be written that way, or y prime, or y double prime. In a parabola, that's a positive parabola, right? Y equal plus x squared is always greater than 0. Therefore, it's concave up, right? But if you look, and by the way, the first derivative equals 0 when? Whoops. First derivative equals 0 when? Okay, equals 0 when y prime equals 2x equals 0, so x equals 0. So at x equals 0, you have a critical point. Right there. And to the left of it, when x is less than 0, meaning this way, y prime is negative. Meaning it's less than 0. Therefore, it is downsloping. The slope is negative. And there it is, right here. The slope is negative. When x, how do I get out of this? When x is greater than 0, y prime is positive, right? You plug in any positive number there, you're going to get a positive number there, and the slope is positive. So therefore, x equals 0 is a minimum. You already know that because the second derivative is greater than 0, right? And therefore, it's also a minimum because it's concave up. Okay? So what that means is, in a parabola, over here, we have f double prime is positive. Over here, f double prime is positive, right? Because it's both of them are concave up. But over here, f prime, first derivative is negative because there's a negative slope, right? And over here, f prime is positive because there's a positive slope. Okay, so if you just draw a parabola and think about it, it's always concave up. It's always concave up. and it switches from a negative to a positive slope, and therefore this is a minimum. Now, if you do the opposite, and draw a downward parabola, what's it going to be? Without going through all of it, we'll just do it. So what we have here is f double prime is what? Over here and over here, f double prime is negative. So this is negative, and this is negative because it's concave down. Right? Concave down is a frowny face, and a concave up is a smiley face. There you go. But now, what do we got for the first derivative? First derivative is, it's positive. See, the slope is positive, and the slope is negative. Okay? So you can remember that. And then for a good one with an inflection point, because if you have an inflection point, that would be something like y equals x cubed. So the first derivative equals 3x squared, which is a parabola, right? The second derivative is 2 times 3 is 6x, and that's a line like that, right? So so we know it's going to go from well, let's draw the function. Y equals x cubed is something like, y equals x cubed is something like this. That's bad. But anyway, at x equals 0, y equals 0. So you're going to have something going on here. And by the way, we know it's concave up here, right? Concave up, so the second derivative is positive. See that? That's positive. Up. This is concave down. So second derivative is less than 0, right? So when the second derivative goes from negative to positive or positive to negative, it's going to be right there. That's called an inflection point. But what does the first derivative do? What's the first derivative going to do? Well, down here, the slope is positive, right? Let's do a different color. Slope is positive right there. So the first derivative is positive, and over here, it's still positive. See? First derivative is positive. So there you go. You go from positive slope, concave down, positive slope, concave up. The big thing here with y equals x cubed is you change from concave down to concave up, and that's called an inflection point. So I hope that helps. Bye.